This is Dr. D. Govardhan, Professor in the Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Okay, today the topic is the discussion of total question bank of Module 1, Introduction to Engineering Mechanics. The problem is a particle is placed upon three forces equal to 50 newtons, 100 newtons and 130 newtons along three sides of an equilateral triangle taken in order. Find graphically the magnitude and direction of the force. Here, the figure 1a is representing the space diagram of forces acting on a triangular object. Here on bottom face, here it is represented AC, A 50 newtons, and B 100 newtons, and C 130 newtons taken in order. That means tail and head fashion it is acting. So the triangle is equilateral triangle as shown in figure. The procedure for the finding the magnitude of resultant and direction of resultant force by graphically is represented as shown in figure now. First of all, the magnitude is represented on a diagram by selecting suitable scale. Here I am taking the magnitude of force 1 Newton is representing 1 mm. The direction is taking the direction which is acting along the equilateral triangle shown in space diagram. Here the force 50 newtons is representing on a side A. Assume it is represented as A and B, where A is representing the tail position and B is representing the head position. So the distance between A and B is representing the 50 newtons, that is 50 mm, which is representing both in magnitude and directions. Now, to represent 100 newtons force now, from the head of the force here now, draw a line parallel to edge represented here B to represent a magnitude of 100 newtons, both in magnitude and directions along the line BC. Similarly, to represent the 130 newtons, which is acting along the side C as shown in figure, is represented as CD, 130 kilometers, that is 130 mm, to represent both in magnitude and directions. Here the closing side of a polygon, that is we have to join D and A. The DA is representing the resultant of these three forces, but it is acting in opposite directions of the order now. That is the forces are AB, BC and CD we have taken, but the resultant of all the forces is represented as AD. Here it is representing both in magnitude and directions. By measurement we find that the magnitude of resultant force is equal to 70 newtons and making an angle of 200 degrees it is given now, just measured in anti-clockwise directions. Now, a second problem. The following forces are acted at a point 2. Assume A2O as shown in figure. The first force 20 newtons inclined at 30 degrees toward the north of east and 25 newtons toward the north, 30 newtons toward the northwest and 35 newtons inclined at 45 degrees toward the south of west. Find the magnitude and direction of the resultant force. According to the Bohr notations are tail and head position. First of all, select one point P. Draw a line horizontal to represent the inclinations with respect to the datum lines or the horizontal reference line. If the forces which are acting according to the space diagram when it is represented, 30 degrees the P force is acting now, measured in counterclockwise direction with the east now. Afterwards, 30 newtons is there now, 45 degrees with the west directions, and 35 newtons at an angle of 40 degrees with the west, and one more force 25 newtons is there, it is acting just north as shown in figure. So according to the given problems, represent the direction of forces which are acting at a point O as shown in figure 2A now, that is space diagram. By using the space diagram, draw the polygon of forces. According to the law of polygon of forces, all the forces are represented as both in magnitude and direction of sides of a polygon. The closing side of the polygon is representing the resultant of all the forces but taken in opposite order. Here we are taking that the P is nothing but reference point now, making an angle of 30 degrees as shown in figure, of length 20 newtons. So here we have to select the suitable scale. The suitable scale is here 1 Newton is representing 1 mm now. That is represent a line of P2 is equal to 20 mm, which is at an angle of 30 degrees is representing the force P as shown in figure now. Again, in tail and deflection order is required now. From Q draw a line to make an angle of here 25 degrees, that is nothing but here now vertical line 25 degrees as shown in figure to represent the force of 25 newtons. Afterwards, parallel to the OS force, draw lines OS, that is RS, making an angle of 45 degrees. It is there now, that is parallel to the force. And from S to R, draw line of length 35, which is a parallel to the this OT as shown in figure. That is, we represented 4 forces, both in magnitude and directions, according to the Bohr's notations are tail and A2 position. The resultant force is representing the closing side of the polygon, that is the T and P, but taken in a opposite order now. So join T and P, make notation opposite directions. That PT is representing the resultant of these 4 forces, both in magnitude and directions. So by measurement we found that its length is equal to 45.6 mm, that is 45.6 newtons, and acting at an angle of 132 with the horizontal, that is the east-west line. Okay, these 2 problems will be solved by using graphical method to find the resultant of system of forces which are acting on a object. The second method is analytical method. That is, each force is resolved into 2 rectangular components, preferably in horizontal and vertical directions. The sum of the components of forces which are acting in horizontal direction is treated as the x component of the resultant force, and some of the components of forces which are acting in vertical directions are treated as the y component of the resultant force. Hence, the magnitude of resultant force is given by R is equal to under root of sigma fx whole square plus sigma fy whole square, and the inclination of the resultant force with the horizontal is given by theta equal to tan inverse of sigma fy divided by sigma fx. This procedure for the determination of resultant force when the system of forces are acting on a body is called analytical method. That is by resolving the forces into two rectangular components. Here we are taking one problem now. A system of forces are acting at a corner of rectangular block as shown in figure. Determine the magnitude and direction of the resultant force. Here I am taking the object is A, B, C, D are the representing the square now or the rectangle. Here the forces are acting 20 newtons, 35 newtons, and 25 newtons and 50 newtons as shown in figure. In order to find the resultant of all the forces by using analytical method, the algebraic sum of the component of forces which are acting in the horizontal direction, 6 directions, is treated as horizontal component of resultant force. But here in the algebraic sum of the component means the forces which are acting in the right hand side directions are treated as positive force, and toward the left side are treated as the negative forces. For vertical directions, the forces which are acting in upward directions are treated as positive. The forces which are acting in downward directions are treated as negative forces. Here, after resolve the forces in horizontal, the sum of the component of forces along the horizontal direction is given by, here one is a 25, one more is a 20. The 25 force is acting toward the right hand side. Hence is treated as positive force. 20 kilonewtons the force acting toward the left side is treated as negative. Hence sigma h is equal to 25 minus 20 is equal to 5 kilonewtons. Similarly, resolve the forces vertically. The forces which are acting upward direction are treated as positive and downward forces are treated as negative. Here in this problem, the 35 kilonewtons acting in downward direction is negative. 50 kilonewtons also acting downward directions is treated as negative. That is here total force is equal to minus 50 plus minus 35 equal to minus 85 kilonewtons. The magnitude of resultant force is equal to under root of sigma h whole square plus sigma b whole square, which is equal to 5 whole square plus minus 85 whole square under root. It is equal to 85.215 kilonewtons. Okay, it is treated as a resultant of the four forces which are acting along the edge of the rectangle. Let theta be the representing the inclination of the resultant force with the horizontal. Then tan theta is equal to sigma v divided by sigma h now, minus 18 divided by 5, which is equal to here now 86.6 degrees. But here now the sigma h is a positive and sigma v is representing the negative. That is when we are taking the coordinate plane now, here x and x dash and y dash. The inclination with the horizontal plane is given how much it is here, 86 degrees like is given here, because here according to our problem now, the by that is the vertical component is a negative and horizontal component is a positive. That means it belongs to fourth quadrant now. Hence in the fourth quadrant you have to represent the resultant of these four forces. With the inclination theta is equal to how much it is? 86.6 degrees. But generally the inclination is measured in counterclockwise directions. on the x-axis, that is this inclination now. Here it is equal to 360 minus 86.6 degrees, which is equal to 273.4 degrees. This is our required answer. The problem number 4. The forces are 20 newtons, 30 newtons, or 40 newtons, 50 newtons, and 60 newtons are acting on one of the angular points of the rectangular polygon pentagon toward the other 5 angular points taken in order. Find the magnitude and direction of the resultant force of a given force system, which is shown in figure 4. Here, A point is treated as one corner now. The 5 forces are passing from the corner, and the direction is moving toward the remaining 5 corners of the pentagon as shown in figure. That is, A is nothing but here the lateral position starting point where the forces are acting. AB, one force, and here the 5 forces are shown in figure now. All are acting at a point A and passing through a point B, C, D, E, F as shown in figure now. The first force 20 newtons is representing along the edge AB and 30 newtons CAC, and similarly AD is equal to 40 newtons, A is equal to 50 newtons, and AF is equal to 60 newtons as shown in figure. The inclination of all the forces with respect to the horizontal line is given by 30 degrees plus 60 degrees plus 90 degrees plus 120 degrees as shown in figure. The resultant of all the forces is obtained according to the analytical method. First, resolve the forces into 2 components. One is along the x directions, one more is along the y directions. Here the first force is there now, AB, it is an horizontal now. It is having only one component, x component. There is no y component now. The second force is there now. It is making an angle of 30 degrees. Having magnitude is equal to 30 newtons. It can be resolved into 2 components as shown in figure like this. That is, horizontal component is moving toward the right hand side. The vertical component is moving upward direction, so both are treated as a positive. Similarly, AD when it is resolved into 2 components, here I am drawing the 2 components like this. Horizontal component is moving toward the right hand side, vertical is again moving upward directions. The fourth force is there, 50 newtons vertically, it is having only one vertical component, there is no horizontal component. Again, it is acting upward direction, it is treated as a positive. Similarly, fifth force now, 60 newtons, it is acting an angle of 120 degrees with the horizontal. When you resolve the forces, this is having components like this. That is, horizontal component is moving toward the left side and vertical component is the upward direction. So, this inclination is now becomes it is equal to 60 degrees and so on. Now, taking algebraic sum of horizontal forces acting at A, that is system of forces equal to 20 cos 0, 30 cos 30, 40 cos 60, 50 cos 90. Last one is 60 cos 120 degrees now. That is passing through second quadrant. Hence, it is the values is treated as the last force is negative, cos 30 equal to minus 0.5 now. So 20 into cos 0 is equal to 1, 30 into cos 30 is equal to 0.86, plus 40 into cos 60 is equal to 0.5, plus 50 into cos 90 is equal to 0, plus 60 into cos 120 is equal to minus half 0.5. The total values is equal to 36 newtons as shown in equation number 1 now. Similarly, resolve the forces vertically, that is at right angles to the horizontal and AB. All are moving upward directions, hence all the forces are treated as positive forces only. 20 into sin 0, 30 into sin 30, 40 into sin 60, plus 50 into sin 90, plus 60 into 120 now. So, which is equal to 151.6 newtons. The magnitude of the resultant force is equal to R is equal to under root of sigma h whole square plus sigma v whole square, which is equal to under root of 36 whole square plus 151.6 whole square, which is equal to 155.8 newtons. The direction of resultant force is obtained by using the relations tan theta is equal to sigma v divided by sigma h, which is equal to sigma v is equal to 151.6 divided by 36, which is equal to 86.6 degrees. That means the resultant of these 5 forces having the magnitude of 155.8 newtons and acting at an angle of 86.6 degrees with the horizontal AB as shown in figure like this. This is called resultant now. It is making an angle of 86.6 degrees. Problem number 5. The following forces are acted at a point are shown in figure 5. 20 newtons inclined to 30 degrees toward the north of east. This is shown in a figure now. 25 newtons toward the north, that is vertical directions. 30 degrees towards north and west. Here it is given 30 degrees. And 35 newtons is acting 40 degrees toward the southwest. Find the magnitude and direction of the resultant force. Now, first of all, resolve the forces along the horizontal direction and vertical directions. That means, according to this figure, in the direction of east and west, the first force is acting 20 newtons represented here now, 30 degrees, 25 newtons according to the figure, vertical, and 30 newtons acting at an angle of 45 degrees, and 35 newtons is acting at an angle of 40 degrees with respect to the horizontal line now. Now, after resolve the forces, first force 20 newtons, here horizontal and vertical. The horizontal component is acting toward the right hand side positive. Vertical forces again upward direction positive. Again 25 newtons is acting upward directions. 30 newtons is acting here horizontal is nothing but toward the left hand side and upward directions. And here toward the left side and downward directions. The sigma h is equal to, that is sum of the horizontal components of system of forces is equal to 20 cos 30 positive, 25 cos 90 plus 20 cos 135 degrees plus 35 cos 220 degrees. We are taking all the angles measured from east and in counterclockwise directions. Hence, the values of cos 30 is equal to 0.866, that is 20 into cos 90 is equal to 0, cos 135 is equal to negative of 0.707 plus 35 into cos 220 is equal to again minus of 0.766 newtons. So the total value is equal to minus of 30.7 newtons. Resolving all the forces vertically, that is along the north-south line, sigma V is equal to 20 sin 30 positive. Second one is plus 25 into sin 90 positive. Third one is 30 sin 135 positive. And fourth one is given here 35 into sin 220, but it is acting in downward directions. So the total value is equal to sin 30 is equal to 0.5, 20 into 0.5. Sin 90 is equal to 1, 25 into 1. 30 into sin 35, it is the second quadrant, sin is a positive, which is equal to 7.07. And in third quadrant, sin is negative, 35 into minus of 0.6428 newtons. So total now becoming 33.7 newtons. The magnitude of the resultant force is equal to under root of sigma h whole square plus sigma v whole square, which is equal to minus of 30.7 here now plus here now sigma h is equal to minus of 30.7 now, and sigma v is equal to 33.7, hence under root of minus of 30.7 whole square plus 33.7 whole square, which is equal to 45.6 newtons. This is treated as the magnitude of resultant force. The direction is given by tan theta is equal to sigma v divided by sigma h, which is equal to 33.7 divided by minus 30.7, which is equal to minus of 1.098, or theta is equal to 47.7 degrees. Here, sigma v h is treated as negative values now, that is x component is the negative, and y component is the positive. Hence, according to the coordinate system now, it belongs to second quadrant. That is, the resultant force is the inclination of the resultant force lies between 90 to 180 degrees. But here the values which is obtained, it is measured in the direction of x-axis, that is the east and west directions. Hence, the theta is equal to 180 minus 47.7 degrees, which is equal to 132.3 degrees, as shown in problem. Equilibrium of forces, Lami's theorem now. Here, equilibrium of forces means when the system of forces are acting on a body, if the effect of all the forces which are acting on the body is equal to 0, then the body is said to be equilibrium. That is, the resultant force will be equal to 0. It will happen when the sum of the component of forces which are acting along the x direction should be equal to 0, and sum of the component of forces which are acting along the y direction also equal to 0. That is, sigma h is equal to 0, again sigma v is also equal to 0. Okay, this type of problems when the three forces are acting at a point 2, these forces can be analyzed, that is, the unknown quantity can be determined both in magnitude and directions by using two methods. One is according to the Lami's theorem, the second one is analytical method, that is by resolving the forces along the x direction and y directions. According to the Lami's theorem, when the three forces are acting simultaneously at a point 2, see as shown in figure, when the body is in equilibrium, each force is proportional to the sine of the angle between the other two forces. That is according to this problem now. That is the force A divided by sin 135, it is equal to the magnitude of B force divided by sin of 150, which is equal to 15 divided by sin of 75 degrees now. Okay, this is according to the Lemi's theorem. Now, just we have to solve these problems by using Lemi's method. Here the problem is an electric light fixture weighing 50 newtons hangs from a point C as shown in figure by two strings AC and BC. The string AC is making an inclination of 60 degrees to the horizontal and BC at 45 degrees from the vertical as shown in figure. Using Lemi's theorem, otherwise determine the forces in the strings AC and BC as shown in problem. The given data in the problem is the weight of the lamp is given, which is acting at a point C is equal to 50 newtons. Let the tension in the strings AC is represented as the TAC and in BC is equal to TBC as shown in figure now. This force is equal to TAC, TBC and 50 Newton force. This is nothing but weight of the light fixture. Now, according to the Lemi's theorem, the magnitude of each force is proportional to the sine of the angle between the other two forces. Okay, according to the geometrical construction now, the inclination here it is equal to the between the forces, but it is also equal to 45 degrees, 90. This is equal to 90 plus here 120. The remaining angle is equal to, that is this angle is equal to 730. The remaining angle is equal to 75. So in figure now. Now, according to the Lemi's principle, 15 divided by sin 175 equal to the TAC divided by sin 135, TBC divided by sin 150 degrees now. Our TAC is equal to 15 into sin 45 divided by sin 15 is equal to 10.98 newtons. Similarly, TBC is equal to 15 into sin 30 divided by sin 75, which is equal to 7.276 newtons. So, this is nothing but we can determine the magnitude of each force directly by using the simple equations according to the Lemi's theorem. Now, problem number 10. A string ABCD, here A, B, C and D attached to a fixed point at A and D as two equal weights of 100 newtons, 1000 newtons attached to it at B and C as shown in figure. The weights rest with the portions AB and CD inclined at angles as shown in figure. Find the tension in the portions AB, BC and CD of the string if the inclination of the portion BC with the vertical is 120 degrees. The load at B according to the given data, the load at B and at C equal to 1000 newtons. For the sake of convenience, split up the string ABCD into two parts now. The system of forces acting at a point B as well as at a point C, we have to consider it separately. Now, when I am taking the forces at a point B now, assume TAB is representing the tension in the portion of AB of the string. TBC is representing the tension in the portion BC of the string. 1000 is the weight that is attached to B as shown in figure. The object is now under equilibrium when the three forces are acting at a point B. According to the Leibniz principle, the magnitude of each force is proportional to the sine of the angle between the other two forces. Hence, here the inclination is now becomes here this inclination is equal to 150 degrees. Here it is equal to 60 degrees. This inclination is equal to, again the total inclination, so it is equal to 90 plus 60 is equal to 150 degrees. Now, according to Leibniz theorem, TAB divided by sin 60, here 60 degrees is given, which is equal to TBC is given, TBC divided by sin 150, it is equal to TAB divided by, here now, sin 150 and shown figure. That is here 100 divided by sin 50 now. That is once again TAB divided by sin 60 equal to TBC divided by sin 150 degrees equal to 1000 divided by sin 150 degrees now. Here in order to determine the unknown values of TAB and TC, just choose the TAB equations and 1000 divided by 150 to determine TAB. Similarly, in order to determine the TBC, just take TBC equal to 1000 by 150 degrees now. Now, according to that relationship, TAB is equal to 1000 into sin 60 divided by sin 30, which is equal to 1732 newtons. Similarly, TBC is equal to 1000 into sin 30 divided by sin 30, it is equal to 1000 newtons. Now I am considering the forces which are acting at a point C. Let us see the three forces are acting in the direction of D, in the direction of B, and one more is particularly downward direction 1000 meters. That means the point C is now under equilibrium when it is subjected to three forces as shown in figure. The inclination is here now 120 degrees and 120 degrees and one more is also 120 degrees now. Hence, according to the Leibniz theorem, TCD divided by sin of 120 equal to TBC divided by sin of 120 degrees equal to 1000 divided by sin of 120 degrees now. So, from this relationship we got to TCD is equal to 1000 newtons now. So, by using the combination of these two locations B and C, we can determine the forces which are acting within the string as shown in the problem. Here, similar problems. Problem number 11. A light of string A, B, C, D, E, A, B, C, D, and E, whose extremely A is fixed now, as weights W1, W2 attached to it at to B and C. It passes around a small smooth peg at D carrying a weight of 300 newtons at a free end E as shown in figure. If the body is in equilibrium position, BC is in horizontal now. This is in horizontal. And AB and CD makes 150 degrees or 120 degrees with the BC. Then find the tension in the portions AB, BC and CD, AB, BC, CD within the given problem. Now, when we are using Leibniz principle, consider the forces which are acting at a point B. and determine the values of tension in the string AB as well as the BC. Similarly, again consider the point C. Again it is equilibrium under the forces, the tension in the CD and the weight W2 as well as the BC as shown in figure. Now by using the conditions to determine the tension in the string according to the Lami's principle. Now when I am considering the forces at a point C, here along the D 300 Newton is acting now. W2 weight is acting downward directions. BC portion is already given in R100 directions. So the inclination now becomes 120 degrees. Here it is equal to 90 degrees. It is the remaining angle is equal to, that is 150 degrees. Now T AB is representing the tension in the string AB. TB is representing tension in the string BC. But now applying Lami's principle at a point C, that is TBC is divided by 150 degrees is equal to W2 divided by sin 60 is equal to 300 divided by sin 90. From this relation, so we got to TBC is equal to 300 into sin 30, which is equal to 150 newtons. Similarly, W2 is equal to 300 into sin 60 divided by sin 90, which is equal to 259.8 newtons. That is, just we got the tension in the TBC as well as the W2 also we got it now. Now applying Lami's equations at a point B, the forces which are acting, one is along the string BC as shown in figure. Earlier already we determined, but the tension is always acts in opposite directions at which the point is considered now. Both are here now, earlier considered it is now acting toward the left hand side, here it is acting down right hand side. Both are having equal in magnitude acting in opposite directions. Hence, this is treated as a known quantity now. And TAB we have to determine now how much it is there, and W1 is equal to. Now applying Lami's principle at a point B, according to this principle, TAB divided by sin 90 is equal to W1 divided by sin 50. It is equal to 150 divided by sin 120. This angle is equal to 120 degrees now. From this relation we got TAB is equal to 150 divided by sin 150, which is equal to 173.2 newtons. W1 is equal to 150 into sin 50 divided by 120, which is equal to 86.6 newtons. So from these two relations we got the tension within the string as well as the weights attached to B and C within the problems. So the W1 is equal to 86.6 newtons and the W2 is equal to 259.8 newtons. Moment of Varignon's theorem and coupled. The Varignon principles generally used to determine the resultant of parallel forces are acting on a body. Here I am taking the problem number 12. Two unlike parallel forces of magnitude 400 newtons and 100 newtons are acting in such a way that their line of actions are 150 mm apart. Determine the magnitude of the resultant force and the point at which the force is acting now. Here AB is given now, two parallel forces are acting which are at a distance of 150 mm apart. 400 newtons is acting in downward directions, 100 newtons is acting in upward directions. Okay, now the resultant force is equal to, since it is not treated as sum of the vertical forces, algebraic sum of vertical forces. Here the forces which are acting upward direction are treated as positive and downward direction forces are treated as negative. Hence the resultant force is equal to minus 400 plus 100, which is equal to 300 newtons. Minus sign is representing it is acting in downward directions. Now, in order to determine the point at which the resultant force is acting now, let x be the representing the point at which the resultant force is acting from point A as shown in figure. Now, according to the Varignon principle, the moments created by the component of forces which are acting at any point should be equal to the moment created by its resultant at that point. Now, we are taking the moments created by the forces now. Here it is equal to, okay, when I am taking the moments at A, that is the sigma A is equal to, when you are taking, at this point, the moment created by the 400 Newton is equal to 0, and the moment created by R is given now, and it is also we can determine. But when you are taking the moments, the moment created by the resultant force is equal to, it is equal to, at a point A is equal to R into X. R is equal to 300 is given, but it tends to rotate the body in clockwise directions. Generally, the clockwise movements are treated as negative. Hence, minus 300 into X is equal to 400 into 0, because here the point of application also coincided with the A point now. And it is given now here 100 into 150 now. Okay, from this relation now, we got it now. 300 into X is equal to 15,000 now. X is equal to 15,000 divided by 300, which is equal to 50 mm. Now, similarly, problem number 13. A uniform beam of AB of weighing 100 newtons and 6 meters long had two bodies of weight 60 newtons and 80 newtons suspended from its two ends as shown in figure 13. Find analytically the magnitude of the force and what point the beam should be supported so that it may be raised horizontally. So the given data is now the beam is horizontally it is there. At A and B 60 newtons and 80 newtons are acting. At C there now the total weight of the body that is assumed to be concentrated, which is equal to 100 newtons as shown in figure. So just we have to identify at what point the beam should be suspended so that it should be in horizontal position. That means first of all we have to find the resultant of the three forces. Since it is a keeping in equilibrium position, that is called equilibrium, which is always acts in opposite direction in which the resultant of all the forces are acting on. So here now the weight of the rod is equal to AB equal to 100 newtons. It is acting in the middle. Length of the rod is given 6 meters. The weight of the body suspended at A is equal to 60 newtons. The weight of the body supported at B is given 80 newtons now. Let X be the distance between the point B where the beam should be suspended so that it can be in horizontal position. Now taking the moments of the weights about D and equating the same now. Just we are having now 80 into sigma D is nothing but we are taking at this point now. That is 80 into x is equal to, it is nothing but it tends to rotate the body in clockwise directions. Here is the anti-clockwise directions. It is also anti-clockwise directions. That is the sum of the movements created in anti-clockwise directions should be equal to the movements created in clockwise directions, which is equal to 80 into x is equal to 60 into 6 minus x plus 100 into 3 minus x. From this relationship we got to 2.75 meters. That is at a distance of x that is equal to 2.75 meters. The object is should be suspended so that it should be in a horizontal position. Okay, what is the reactions within the string is equal to? It is equal to sum of the forces which are acting in downward direction will be equal to the sum of the forces acting in upward directions. Hence, the resultant is equal to, we are having 60 plus 100 plus 80, which is equal to 240 newtons. But it should be acting in upward directions now, because it is keeping the body in a equilibrium position. Problem number 14. A horizontal line PQRS 12 meters long, where PQ is equal to 4 meters, QR is equal to 4 meters, RS is equal to 4 meters. Forces of 1000 newtons, 1500 newtons, 1000 newtons and 500 newtons acted to P, Q, R and S respectively in downward directions. The line of action of these forces makes an angle of 90 degrees, 60 degrees, 45 degrees and 30 degrees with the PS. Find the magnitude and direction and the position of the resultant force. First of all, resolve the forces along the x direction and y directions. First one is 1000 newtons acting downward directions. It is not at all having any x component. The second one is 1500, 1500. It is acting downward direction, so x component is toward the left hand side. Similarly, 1000 newtons at a point R. Again, it is acting downward direction, so toward the left side. And S, 500 newtons, it is acting downward direction, so but toward the left hand side. That's x component is having now. That is the x components, horizontal components are acting toward the left hand side according to this problem now. Okay, the sum of the horizontal components is equal to 1000 cos 90 degrees plus 1500 into cos 60, 1000 into cos 45 degrees plus 500 into cos 30 newtons. Finally, we got this value is equal to 1890 newtons. Similarly, resolve the forces in vertical directions. So, sigma B is equal to 1000 into sin 90 plus 1500 into sin 60 plus 1000 into sin 45 plus 500 into sin 30 newtons, which is equal to 3256 newtons. The resultant of all these four forces is obtained by square rooting sigma h whole square plus sigma v whole square, which is equal to under root of 1890 whole square plus 32, 3256 whole square, which is equal to 3765 newtons, which is acting in downward directions. Similarly, the direction of the resultant force is equal to, let theta is representing the direction of the resultant force with the horizontal. So tan theta is equal to sigma v divided by sigma h, which is equal to 32,3256 divided by 1890. equal to 1.722 now, which is equal to 59.8 degrees now. The position of the resultant force. Let x be the distance between the point P and the line of action of the resultant force. According to the Wagner principle, assume this is nothing but representing here now. Somewhere x point it is there. The resultant force. Theta value is also given, which is equal to 59.8 degrees now. So according to the Wagner principle, the moments created by all the component of forces at a point P should be equal to the moment created by its resultant force at that point. That means when you are taking the moment is equal to force into perpendicular distance required now. Hence, only the vertical component is required for the determination of position of resultant force acting on a beam. So, which is equal to 3256 into x. It is equal to 1000 into 0. That is equal to similarly 1500, the second one, into sin 60, which is equal to 0.8664, into distance is equal to 4 is given. Third one is the force 1000 into sin 45 is given, into the distance is given 8, plus 500 is given, that is equal to sin 30, 500 into sin 30 is equal to 500 into 0.5 into 12, which is equal to 1308.52. It is given now, which is equal to vertical component multiplied by the x distance. So x is equal to 13,852 divided by 3,256, which is equal to 4.25 meters. Okay, resolution of a force into force and a couple now. A system of parallel forces are acting on a rigid body, as shown in figure 15. Reduce the system of forces to a single force and couple at a point A, and a single force and couple at a point B. The given now, the forces A, B, C, D are given. One is at A 32.5 newtons, at C 150 newtons, at D 67.5 newtons, and at B 10 newtons as shown in figure. Now we require a single force now. Single force means nothing but all the forces are replaced by single force, which will have the same effect on the body. That is known as a resultant of 4 forces. Here when we are taking the resultant of 4 forces, since all the forces are acting in vertical directions, hence the algebraic sum of the forces in vertical direction is equal to the resultant of all the forces. While taking algebraic sum, the forces which are acting upward direction are positive and downward direction forces are negative. Hence, single force is equal to resultant is equal to R is equal to 32.5 minus 150 plus 67.5 minus 10, which is equal to minus 60 newtons. That is the resultant force is acting vertically in downward directions. Let x be the representing the position where the resultant force is acting from a point A. Then according to the Wagner principle, the moment created by the resultant force at any point should be equal to the algebraic sum of the moments created by its components. So R into x is equal to minus 150 into The first one is 32.5, it is equal to 0 because the distance is equal to 0 only required. The second one is 150 into the distance equal to AC. AC is equal to 1 meter. It is acting in clockwise direction, so generally it is treated as negative. So minus of 150 into AC. The second one is here anti-clockwise directions, positive. That is 67.5 into AD. AD is equal to 1 meter plus 1 meter is equal to 2 meters. Similarly, at B, it is again tends to rotate in clockwise directions. Hence, it is the negative values. That is a 10 into AB. AB is equal to, this value is equal to 1 meter plus 1 meter plus 1.5 meters is equal to 3.5 meters. From this relationship, we can get the values of x is equal to 0.833 meters. That means these all the forces can be replaced with a single force of having 60 newtons acting downward directions at a distance of 0.833 as shown in figure like this. A single force and a couple at a point A now. So that nothing but this force whatever be there, we are changing to position A as shown in figure now. So the magnitude of the couple is equal to, then when I am taking it a point here, 60 into 0.833, that is the distance given. It is a tends to rotate the body in clockwise directions, which is equal to 49.98 Newton meter. That is here now. This can be reduced now. The forces are acting in here both. It is there. These two forces are tend to couple in clockwise directions. Hence, when we are reducing the force at a point here now, it can be written as now 60 newtons, which is acting now. That is, it can be represented as 60 newtons, and a force of equal to 60 into 0.833, that is the couple acting in clockwise directions. That means this force can be shifted to point A by adding the same force of same magnitude in the same direction, so with the addition of a couple which is equal to 60 into 0.833 Newton meters. Similarly, when the force that is the resultant force at E, when it is shifted to a point B now, exactly now, it can be obtained here at B. Just both the forces are having same magnitude and direction, so we have to keep it at a point B. But these two forces tends to rotate the body in anti-clockwise directions. So it is equal to 60 newtons is acting. The couple is equal to 60 into the perpendicular distance between these two forces is equal to 2.667. This force, this couple is acting at a point B now. So which is equal to, you can take it as 160 Newton meters now. Okay, this is the general procedure we are following now. When the point of application of the force, when it is shifted to at other point, the same magnitude of force that exists with the addition of couple now. Okay, these are the important problems we discussed in the first chapter now, that is introduction to engineering mechanics. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.